methods and estimation of a ore deposits. After formation of a ore, and we have conducted various methods for sampling, like that is geophysical exploration, geochemical, and geological exploration. After completion of those exploration methods, now we will go to for drilling. In this drilling section, we have some methods. These methods, if it is depend on our possibilities of investigation for different mineral deposits, we'll have a choose those ore deposits where we have identified, divide into the blocks, and these blocks depend on their our expense, and we'll calculate all the expenses, cost, how much we are going to bear. Based on these all, we keep in our mind, and we'll go for drilling methods. In some investigations, actually drill holes, it is a secure for a geological information. It's a giving the clear information to us what it is a position and what it is a formation of a mineral deposit attitude, and we'll get information the sequentially how it is formed stratigraphically. That means the rock beds how they were formed under the surface. It's a depend on the stratigraphic column. We'll get this type of information if we'll go into the drilling method. Yes, in some types of vein areas, we'll get the vein deposits also, but we don't know where that veins were coming. For that purpose also, if we cannot chase these drilling method, we'll go into the deeper level of earth surface, and where it is that vein originated, and the birthplace also we have to know. The sampling of it's a taking, if we will take a very small portion, and the small portion of a sample, it is a representative of the whole of a sampling area. Generally, we know the term it is a ore assay value. Ore assay value means if you are collected the sample from the ore, the sample it is a representative for the whole amount of a ore deposit. Such type of ore it is called assay value of the ore. Although the usual reason for sampling or a mine or a mineral property, it primarily it is a depend on the economical point of view. The results whatever it's giving to us, and it's a truly it is a depend on the whatever geological formations it have. Based on that, we can say that it's a what type of a deposit it will be there in that one. So now if you can go into the drilling. Yeah, drilling or bore, it is a process It is a major process to driven the holes into the rock surface or into the outcrops. What is a principle? It's a cutting during this is a drilling. It's a cutting the rock surfaces, and after cutting of that, we'll get some material, and this is for a chemical tests and chemical analysis, and we can use these prime thing. The main purpose it is for exploration. It's a mineral exploration point of view. These drilling techniques will be useful to us. Yeah, drilling methods, and it has a types of drills. There are five types of methods in your drilling. Those are percussive, attritive, rotative, cutting, rotative shearing, and rotative crushing. These five types of methods we are using in drilling methods. The first one it is a percussive drilling. In a percussive drilling method, the rock is broken by repetitive impact, by repetitive impaction. That means it's a repetitively we are pressing. Repetitively we are pressing, and the bore drill it will be go inside when we are pressing on this one. And this type of also again it is divided into the five types. There are pneumatic rock drills, down the hole drills, independent rotation, motor drills, and cable churn drills. These five type of these five types of drillings can be used in percussive method. And next one it is attritive drilling. Yeah, it has some special property like abrasive action, and it is also recognized into the two types. One it is diamond drills, one it is a diamond drills, and second one it is a short calyx drills. Second one it is a short calyx drills. Based on these drills, we will following the attritive drilling, but here the maximum the ground awaits abrasive action. That means the ground it has a abrasive action. Based on that action, we will use the two types of drills. And when you come into this is a rotative cutting drill. The rock it is a cut or it's a plant away. Whatever augers having a drilling, these are all methods will be fall in this group. And rotative shearing method. In this method, the rocks it's fermented by a wedge action. Due to this is action, it will be moving. And this group includes drag bit holes, rotary holes, and it contains drag bit holes and rotary percussive drills. Again, we go into the Diamond drilling. In diamond drills, it can be used for surface as well as it will be used in subsurface drilling also. In a diamond drilling, it has a cylindrical bit, or it is called as a cutting tool, and it is impregnated with diamonds. It is arranged by the small diamonds, and it is connected to string. It has a hollow jointed tubes, and those tubes associated with the mechanical devices, and the mechanical devices, it's useful for rotating, and maybe it is a the engine, maybe it is a petrol engine or a diesel engine, or sometimes it has a pneumatic compressor device also. And in not it is useful for in water drilling and mulling drilling mud, and in sometimes we can use in this in some cases air circulated method. That means it's having the hollow tubes. Through this tubes, the air it will be circulating. It is a moving up and down, and it is filled by the oil also sometime because of it is giving the coolness. It's giving the coolness where we are cutting with a bit. Sometimes if it is getting a very hot when we are drilling because of the depend on the hardness of it rocks. Sometimes it is getting the hot conditions. So that if you are do the continually, maybe it will be getting the repair. So that must ensure the instrument or the bit we should keep in a cool. For that purpose, give the we have to give this some water or drilling oil or air to pump into the hollow tubes, so that automatically it will become cool. And diamond cutting edge, it's cuts a cylindrical core, and it's penetrates into various rock strata. Because of the hardness of a diamond, it is very high. We know that according to mole scale also, we can see this is a hardness of Yeah, sorry for your interruption. Actually, it is a problem of network. Let's yeah. In a diamond drilling, yeah, diamond drillings which can we can use under the surface, and we can use in the subsurface drilling also. It has connected with the uh, smaller diamond pits in that one, and it is associated with the hollow jointed tubes. And again, in a hollow tubes, it is filled by the little amount of water or drilling oil or drilling mud, and in sometimes we can use air also. Because of it is giving the strength to that one, and it is always keeping it cool. And the diamond strata, when you are cutting this cylindrical cores or whatever, it will be penetrates into the various rock types because of the rocks which are having the different densities or different hardness. So that finally we know that the diamonds which are having according to our Mohs hardness scale system, it's having the more and the more hardness when you are compared with the other minerals. So that we are using the same, the diamond drills, it is the best for drilling of a rock. And such core we can collect in a core barrel, and it is fitted into the above the bed. And then sometimes we'll collect the same with the withdrawal of a tool string, or sometimes we can removing of the only barrel. Then itself we can able to collect these samples. And the next one it is churn drilling. In a churn drilling, a hollow tube has a suspended cable, and it is attached with a cutting tool, and it is driven into the ground. It has a rectilinear motion, and the motion is imported to the bit by continuous dropping and raising of the tool string. It is the fluctuation motions will be there in this case. It is a fluctuating. Sometimes it is a fluctuating, and sometimes it will be not fluctuating. Based on that moment, it will be driven into the deeper side. And the cuttings so generated are collected periodically by at a sludge collector or a baler. Uh, this method actually we are not collectively we are not used in a particular mineral exploration, but wherever the alluvial terrains or residual soil matter will be there we can use this type of drilling. And next method it is rotary drilling. In rotary drilling, it is giving the purely the confirmation of a nature, and it can be interpreted from chips and cuttings, so that there this rotary drilling it is useful. The soil surface or rock surface it's having the like a mode of a chips, or it has a cutting of edges, so that at that purpose or at that stage this rotary type drilling will be useful. And again, if you go into this is a mineral exploration point of view, uh, these drillings we can use most effectively in particular mine exploration stage, when bench drilling becomes it is a necessary, because of when it is a drilling the rock surface of external surface of a body, it will be released or it will be spelled out as a small chips. And apart from this drilling, uh, other methods will be described. whatever methods we have explained to above, the device is like a auger drilling, and it's also used while exploring for a soft and non-compact material like clay and bauxite. Yeah, collection and preservation of a drill samples. After once we drill in that area, how to collect the sample and how we can preserve the same sample when we are completed with the drill sampling. The first one, it is a core samples from diamond drills or various other coring and calic drills. Okay, we can use different methods in drilling. Either maybe it is according to your diamond drilling method or coring or a calyx drilling method. First, wet cutting or sludge from churn drill, or maybe it is a diamond drill, or it is a wet rotatory, or it is a percussive drilling. If it is a dry cutting from the air flush diamond, or if it is a rotary, or it is a auger percussion drilling, whatever method we will follow, we will be follow, maximum almost will have to identify the host rock from which method we are using from the host rock. Or when the core recovery, if it is 100%, and the core it reflects the strata so faithfully. Maybe it is sometimes the 100% core it is recovery, it is not possible. When you go into this is a core drilling. The core drilling principle, it is a sample is collected from the barrel at intervals of 3 or 6 meters or 10 or 20 feet around. That means we will collect the sample for every 10 feet or 20 feet after we have done the core core drilling, and we'll collect the sample from the barrel. The interval it is maybe it is 3 to 6 meters of error. We'll collect the sample for every 3 meters or every 6 meters. Yes, the shorter drill it's a run, and the shorter core lengths are preferred in some cases. After we recover from a barrel, and then the core samples we can, after collecting all this is the core samples from the barrel, we will keep in a core box for some time for a removing of a moisture, because of we are getting these samples from deeper levels. Maybe it has a some underground water also, so that we will get this sample from this is a barrel, and we can keep for some time in a core boxes. And then what's the use of this? Yes, after collection of these core samples, after collection of these core samples, now you can you can cut or you can split into the small sizes, and from this is the small sizes, one part you can send into the for a petrographical studies, or one part you can send into the laboratory study. So based on that we can come into this system for one it is for we can use for the mineralogical study. Petrography means mineralogical point of view we can have a chance to study, and one part it is for that is chemical analysis point of view, that will be useful to us. And next one, it is the collection of a sludge. In the case of non-core coring drills with water circulation arrangement, the Thomson sludge cutter or a sludge box can it will be made use of. The box has a water inlet. Yes, it has a water inlet, and also it has an outlet, and it is uh, divided into the longitudinally by the three plates, baffle plates. When you come into this is a non-core drilling. We can use air removing cuttings, and there are two arrangements will be there in that one. Okay? We can call also this is as a DLR drilling also. It is calling as DLR drilling also. There are two arrangements will be there in this one. One it is which is having a cutting collection, and also it has a collection of arrangement. The small tool will be there, and which can be the periodically reclaim the all the samples. It will be removed sometimes. That means whenever we are collecting the samples, and again automatically it will be removed from that one, and then automatically it will be removed from that one, and then the next sample it will be entered. And the other thing it is to allow the cutting to accumulate the mouth of the drill. Wherever the mouth of a drill it will be there, and we will collect the things sequentially from that mouth. We will collect the very easily from there, and the most thing it is you will get the samples from the very deepest of the strata. Very deepest of the strata means we will collect the samples from the very deeper level. And next thing it is how we can do the calculation. That part it will become under the average essay computation. Yes, once you have a collect the sample, once you have the collect the sample, and then it is clearly, it's a clearly yes the area it has a ore deposit. The area it has a ore deposit. So how we can calculate how much of ore we are getting, or how much of a ore we will be collecting. So that purpose, what we have to do? We have to do some calculations. How much area it is there? What it is requirement, or what it is that calculations? Yes, there are lots of a course varying in amount, and one is the easiest method we have, and that it is the principle we will be follow. It has given by the Indian Bureau of Mines, IBM, that is called. The principle it is A is equal to C by L into D1 square by D2 square, and we can multiply it with using of the differences between the first average value and the second average value of SA. That's maybe it is related to the core SA, or either maybe it is a sludge SA, whatever it is there. That is called A1 minus A2 into A1 minus into uh, A2. Again, we'll calculate the A2. Here again, if you can see these, A, what it is, A, it is the average SA. The average SA, I told you that wherever you are drilling the core based on the core sample or a diamond drill sample, whatever it is there, the sample, whatever it will become to out, that is different for all the total deposit of the area. And see, it is a recovered core. How much core you are recovered? And L, it is indicating the length of a hole. Length of a hole means how much, what it is the depth you have a drilled. What is the depth you have a drilled? That is indicating the length of a hole. And diameter, it's also important. The diameter, it is speaking about the whole diameter. The whole diameter, maybe it is 8 inches or 6 inches or 4 inches or 3 inches of a hole. And the D2, it is the diameter of the core. Yes. If it is an example, first suppose if you are drilling the six end of a borehole. In the six end of a borehole, just we can use the um, core drill. The pins, the core pipe. The core pipe it has a 3 inches or a 4 inches will be there. So this is the diameter. It is a core of a diameter here 4 centimeters. So that these type of calculations we need. A1 is equal to core SA. How much the core it will become at outside and how we can calculate. And second one it is A2. It is that is a sludge SA. The sludge SA means it's a powder material. How it will be releasing to outside and how what it is at the percent. The differentiation we can calculate. And again, we have a chance here. The analysis may be 50 centimeters, 50 centimeters, 1 meter, 3 meters length. It depend on the type of mineralization. Yes, exactly. Suppose if you can see the radioactive minerals or other things. In your radioactive minerals and other things, will get very least amount of a deposit in some area, so that the length of a mineralogical core, the core sample also will get the less in size, like example for a 50 meters 1 meters length, or else if you go into the quartz deposits, or else if you go into the granitic deposits, then you can drill up the length, maybe it is a 1 meter length. Based, based on this, we can yes, and sampling. The elevation of a mineral prospect property is require the examination of a chemical and physical characteristics of mineral accurately as a possible. Just 1 minute, please.
మెడలో మెలకల నాదుల దండ అనుకున్న పడంగా
Yeah, sorry for your interruption. Yeah, sampling. Next state it is a sampling. The evaluation of a mineral prospect for mining property, and it requires the examination of chemical and physical characteristics of the ore or a mineral as accurately as possible. A second thing, it is a sampling how we can done. Sampling it's a process. It's taking very small portions in a particular selected area, and shall be it is a representative of as a whole. The methods of a sampling. The purpose of a sampling, which includes the determination of average growth and a particular tonnage, study of economic viability of mineral prospect, and it is also association of estimation of a reserve, improved deposit.
setting
Yeah, the following conventional methods of sampling are used for different purposes. Yes, there are five methods there. It's a channel or a groove sampling. Sometimes we may follow chip sampling. Sometimes we have a chance to collect the through by the grab sampling and car or wagon sampling, pitting or trenching according to bore, and we'll collect the sample. Yeah, next we go into the channel or a groove sample. In this method, how we can cut this is the sample according to as per channel or across the channel, and it's the face exposed or over or collecting of chips and fragments and the dust from each channel to make up a sample. And these are channels consisting of cutting of a grooves for a uniform section, it's a need, or sometimes we go across the face, and usually at the right angles to the formation, and some custom size of a groove that maybe it is a 1.5 to 4 inches and wide about maybe it is a 1 feet deep, and it's depend on the nature of a material. The spacing of a channels, it's very important. The intervals must it's a close to yield and a representative part of as a whole. And in general, the sample spacing will be closer for a regular deposits or uniform for ore deposits. The sample intervals to be taken. When you go into this chip sampling, the chip sampling says it's a chip of a rock is taken either it's a continuous line or across the exposure or at a random intervals, and it is associated with the labors. Yes, and labor is than channel sampling, and usually it is adapted when quick preliminary results are needed. The ores are hard and uniform, and it is difficult to cut off a channel. When you go into the third level of a sampling, it is a grab sampling. A grab sampling of the muck, it's a blasting. Sometimes it's a taken instead of a channel sampling of a ore and pieces of a rock and cutting into the permanent sizes and be picked up based on our size requirement. This method gives the correct result in some ores or whose values are evenly distributed or independent breakup qualities. And when you go into the wagon sampling, a shovel full of ore or a series of pieces selected and at a random according to the pre-arranged system. It should taken from each car that comes from the mine. A check may be obtained by averaging our car samples for a day and comparing with mill and ahead sample. When we extract these samples, means after crushing, only we will collect the sample from different areas with using of these wagons. Next one, it is a pit, a trench, borehole, or a drill hole sampling. In particularly the mineral exploration, pitting, trenching, and putting the boreholes or drill the boreholes are the very common factor, very important factor also. Based on that, we will collect the sample very carefully. Depend on the nature of a deposit, and different methods of excavations are needed to expose the ore body for a study. Suppose if the pitting or a trenching, it is adapted from the bedded deposit, then we have a chance the deposit of a depth. We can have a chance to deposit to extend the depth and required course also we can extend. If it is favorable to us, definitely we can have a chance to extend this borehole drilling. In this case, the boreholes once if we have completed this study, and again these boreholes maybe either maybe it is a core collection or a chip collection or a sludge collection or whatever collection we are doing, and finally we will do the or we'll get an average of all the samples. And how to redact the sample after completion of your collection of a sample, and we have a reduction of a bulk samples. The process, there is a process for that one. One, it is a pawning, and second one, it is a quartering. Yes, whatever method we are following to collection of a samples, and we definitely we have to do reduce for the requirement of a sizes. The process, it is called here quartering and coning. And what we have to do first? First, we have to do this coning of these all these samples, coning of all these samples. The big size of a sample material, it will be come down, and a small size of a sample, it will be stay in the top. It is working as a cone forming. Sorry. And then after completion of this is a coning, the heavy materials, it will become down, or huge size of a material, it will become down. The smallest material or a fine material, it will be stayed in there, or it will be forming as a cone shaped. So based on this, the sample, it is divided into the four parts. Now you can do the section from top of the cone, and uh, we can divide into the four parts, equal four parts. Okay, this process, it is called coning. That means, sorry, quartering. The first part we are making, that is called as a coning, and second part, it is called as a quartering. Quartering means here the sample sizes, according to the sample sizes, the same what we have made the cone, we can cut down into the four pieces, or you can divide it into the four pieces. This part, it is called quartering. An estimation of reserves, how we can estimate? Yes, definitely we have an estimate. The samples after completion of your analysis depend on the background anomaly, or we can depend on the background, normal background of values, and depend on the threshold values, and depend on the uh, average SA value. Now we have a chance to estimate the ore reserves. What it is thickness of a ore deposit, how much it will be extend, what it is the width. Based on things, we have a chance to estimate the ore. Suppose if you have it done within a 2 hectares of a ore deposit, Yes, the full of area, the 2 hectares of area, it is filled by the 30 meters height of 30 meters height of ore deposit, and then now you can drill into the deeper level of earth also. There we can get the calculation. Suppose if we can drill about 300 feet of depth, the total depth, if it is a ore deposit, now you can calculate from the top 30 meters. Top 30 meters, it is equal to 90 feet. 90 plus these 300 300 feet. Totally, we can calculate this is the 390 feet. And again, the width it is also we need to calculate how much area it is occupied. Now you can convert it into the 2 hectares. You can convert into the feet. How much you will get? We can multiply with that one. The total amount, the total figure, it will be come to you. The total figure it is considered as a ore deposit amount. This is only that you see. Here, the ore volume deposit, if it is computed according to your plan at the section of your maps, if you can use these CCS systems, that means measuring systems, measurement systems, you can use that one, centimeters, grams, centimeters, grams, and seconds. Or again, if you can go into this one, foot, mm, pound, second systems. Okay, if you can measure in this case, now we have a one principle, that is a TF, it is equal to 2000 by 62 point into G. G, again, you can see here 2000 lbs, that's we can measure its ton basis, and G is equal to specific gravity of a ore, and that is maybe it is a 62.2, that's a weight of the what we are cutting of water or whatever it is there is giving that one. But it's an average value, that's average value or a average ton of the factor. And now you can come into the total tonnage, the TF into value, TF into value in a ore deposit. Suppose that is only what I told you. Example, just one of the area, it has a 200 two and a half hectares, and it has a full of laterite deposit, whatever it is there. The height, it is a 30 meters, around 30 meters means 90 feet. And again, based on these 90 feet, now you can drill into a deeper level. Now you can deeper level drill means approximately you can drill up to 30 meters means again again the 90 feet. If you go 90 into 90, you will get some amount, 8,100 feet you will get. The total of 8,100 feet, it has a full of a ore deposit. This is a tonnage of ore we can calculate like this. This is a ore estimated, it's also very important. And again, there are various methods in a ore estimated, geometric method, and again unit spacing method, and a semi-regular spacing method, and irregular spacing method, polygon method, and a triangular method. Based on these methods, we can have a chance to calculate this one. When you come into this is a geometric method. In a geometric method, you can see it is again it is a depend on the uh, depend on the rectangular coordinates. We have a rectangular coordinates, and according to that uniform spacing of 60 on 60 coordinates. And again, uniform spacing method means there are two methods in this spacing. One, it is a extended of area, and another one, it is a included or a limited area method. In this case, extended method, the sample size or the sample area where we have brought from the field, and that is divided into the in the square method, or we can divide into the area into the square. 150 into 150, or the total area maybe they having to 1200 feet into 1200. So based on that, we can divide. That means you can divide that area equally as a square. All areas it should be equal, and you can divide that area into small parts of a grids. And the midpoint of a grid, we will collect the sample. and how much area we are covering, or how much samples we are picking from that area, which sample the distance we should have maintained equally, and we should note everything. You should note everything, and finally it is giving the output in a formation of a tonnage. And second one, it is included area method. Included area method means we can fix the only four coordinates. Within the four coordinates, that means example you see here, A, B, C, D. You see the A, B and C, D. These four sides of coordinates we will fix the quadrant we are calling, that is these are all the quadrants, and two quadrants, the distance we will measure the two quadrants, between the two quadrants and between the two quadrants, so that between this again we will have a chance to divide into the two parts, and between these two parts the distance we'll have to measure by 900 into 900, and it is weighed by the area, average thickness of area also we should convert into this one. And when we go into this is the spacing of a 60 coordinates. In your 60 coordinates, it's a impacting the each sample, or the impacting of each sample, maybe the sample it is in a regular exam level, and the representation of the samples do not vary. That means it's not a differentiation between one sample to the another sample, and so volume it is obtained by the multiplying the total area or exams or average thickness of a deposits. The equal distance we should maintain. And next one, it is the semi-regular spacing. In a semi-regular spacing, actually we will pick up the samples according to the interval, or sometimes maybe it is a extended of the interval or the included of interval. So that the average value we will calculate here, and the sample whatever we are picking from this from the old area, that is a representative for whatever collecting samples, or it is a representative for the total grid, or same interval. So the here sometimes what is happening, the samples maybe it will fall or outside, or we will collect in inside. We'll take the average value in this case. And when you go into this is a irregular space. In a irregular space, there is no particular method. And again, it is a again it is a divided into the two methods. One, it is a polygon method, and second one, it is a triangular method. In a polygon method, you can see here the samples or the area we can divide as polygons, and between this is a polygon, in midpoint of a polygon, we will collect the sample. It is an irregular interval. That means irregular means there is no, we are not following the systematic line or a uh, systematic grid. So that we are calling that is we are calling that is irregular in interval. And one more, the next one, it is a triangle method. In a triangular method, the sample points are joined from where it is a triangle creating. That means where it is a triangle point will be creating. You see here, the area it is creating as a triangles, the area it is creating as a triangles, and each point, you see the each point it is coordinating the two lines, or it's a jointing the three lines, and one line again it is jointing the mid. You see here, one line it is jointing in a mid. It the midpoint it is making triangles all the triangles, and this areas it is giving the multiply by the weight and the thickness, weight and the thickness, weight and the thickness. Based on these triangle values we will get the result of ore. And next one, it is the principles of a mineral economics. Yes, mineral economics actually it is not modern history. It has a old history also. Just when you go into the before Christ, Kautilya, written, he has a written, he has written in his Ardhashastra. What he has written is every mineral or minerals have a specific economic style, or minerals has a specific economic source for a treasure, so that the concept of the minerals in a human history, it is as old of the human civilization. The names of the minerals and their products have been used to uh, christen various areas of civilization, such as the Stone Age, Bronze Age, or Iron Age, and including with the Nuclear Age also. The minerals are playing the very important role to wealthy of resources. In certain cases, in peculiarities of naturally occurring minerals and their important and their impact on industrial economics, and it is the way the emergence of a mineral economics as a special branch of a geology. There are some basic things. Universally, it is recognized, and universally, it has laid the foundation stone, the foundation of a national mineral policy. Some conditions are there. What are those? Those are minerals are depleting assets. Yes, exactly. It's a depleting once if you will mine, or once we will extract, but there is no chance at all to regenerate or reproduce. And the modern industrial economics is based on the minerals and the mineral products. The boundaries of countries bear no relation to mineral geography, and no nation has domestic resources when sufficient for industrial needs. Yeah, minerals and the industries. The most important peculiarity is their non-renewable characters, unlike the flora, fauna, and flora, and it's taken millions of years for time for a geological process, and finally it is formed as a useful mineral. Yeah, minerals again, it has a property of depleting the assets. Once if we can mine, the deposits get exhausted without any chance, and we didn't get any replacement by the same mineral deposits. In a local, when you come into this is a localization of minerals. The mineral deposits are not evenly distributed in various parts of the earth, and but a particular mineral deposit, if you go into this, is a highly it's localized or in any area, and with a it is occurs. For example, for if we can see the international level, the Canada it's producing about the 50 percentage of the world's production of a nickel, and it comes a single nickel producing area in the world, subsidiary Ontario in that place, and which is only the 24 kilometers long and 30 kilometers of 34 kilometers of a wide. And similarly, of world's the molybdenum products come from a single larger deposits molybdenum that it was located in located in Colorado, United States of America. And we have international characters also. As an international character, a logical consequence of a localization of a mineral deposits or minerals, it's occurring the minerals are not confident to man-made or political boundaries. uh, Political boundaries. Yeah, for this process, no nation is self-sufficient in respect of mineral resources. Yes, exactly. Each nation it is depend on other nations. Whatever country you see, only one nation, not only one nation or other nations doesn't have a special particular deposits. All mineral deposits will be not available in one country. And again, they are thus the international some characters. It is unequal distribution also make in the mineral trade. and in the minerals inevitable and involves the political and economic discussions between the countries. Mining problems and unpredictable characters, and this is also playing the very important role in mineral economics. Like some industries or mineral industries which are involving the mining operations, and it is a depend on their mode of occurrences or the formation of a mineral deposits. Sometimes the mining maybe it is open cast, or sometimes maybe it is underground mines, or which are having the own risks and the own problems. And unpredictable nature of a mineral occurrences, it is a mineralization or considerable variations in grade in a given deposits or uncertainties of extent or the persistence, where it is available in a depth or not, which are all will be considered all these things. And the deeper mining, it's beyond 150 meters depth. It will be involves, yes, definitely, it is involving the temperature and the pressure. Because of when we go into the deeper level of Earth, the temperature automatically every 150 meters, the temperature it will be increasing, and the pressure it will be also increasing. So that the temperature